All right, everybody, we're going to do number 1 here on the stoichiometry homework. And for these problems, what you're going to need to do is you're going to need to first come up with a balanced equation. So we've got some steps up here that you might want to take a look at here, 1 through 5. Step number 1, you're going to write a balanced equation. So for number 1, it talks about how we have we're taking Tums, which is a popular antacid, and it's primarily calcium carbonate, and that's going to react with stomach acid, which is HCl. So what I'm going to start off by doing is I'm just going to write HCl, and I'm going to be adding calcium carbonate. So you might need your ion sheet for this, but hopefully you remember that Ca is a +2, and then carbonate, again, you can get that off your ion sheet, is a -2. So when we drop and flop or drop and swap, whatever you want to call it, those are going to cancel out. So we'd get Ca2CO32, which is going to reduce to CaCO3. So what we need to do next is we need to figure out what type of a reaction is that. So you're going to want to look on your predicting reference sheet. So when we look at that reaction, what we see is that we're dealing with 2 compounds. So that's going to be a double displacement reaction. So make sure you're following the steps here. We're going to write out the ions. We're going to switch the ion pairs. I mentioned in class it's kind of like a polka. So what I'm going to do is I'm going to list the ions. So hydrogen is a +1, Cl is a -1, and then I already looked up the charges when I wrote the formula for calcium carbonate, +2 and -2. So what's going to happen is our hydrogen is going to go with the CO3. And so our new formula, then if we drop and swap that, would be H2CO3 plus, we always write the positive one first. So the Ca with the +2 is now going to have a new partner, the Cl, which is a -1. So the +2 from the calcium makes that CaCl2. So our calcium chloride ends up just being kind of like an aqueous solution in our stomachs. But just as a fun fact, that this carbonic acid actually breaks down. You don't need to know this, but it breaks down. If you remember from decomposition, we get CO2. That's why you feel kind of gassy when you take a Tums. And then we also get water. So why is it so effective is it basically takes the acid and it neutralizes it. It takes the acid away, so our tummies feel better. And of course, we don't want to forget to balance. It looks like we have, and I'm just going to ignore this. That was just for fun to talk about that. But our H2, I see, so we're going to put a 2 in front of the HCl. And it looks like that's going to fix our chlorines as well. 2 chlorines on that right side, 2 chlorines on the left, 1 calcium and 1 CO3. And you don't have to do this, but we're just going to put some 1s in front here so that we know what those numbers are. So the new part here would be the stoichiometry. So you have to do the stoichiometry for 7 of these problems, and I'm asking for the balanced equation for 11 of them. So what we just did, you have to do that for all the problems. You only have to do the stoichiometry for 7. So what I'm going to do next is the stoichiometry part deals with the number that's listed here in the problem. So it says, how many grams of stomach acid could 24 grams neutralize? So what I always like to do, is just kind of on a habit, is I like to write that number directly in the equation. So that 24 grams is the Tums tablet, is the calcium carbonate. So I'm just going to put a 24 grams underneath that CaCO3, okay? And what we want to figure out, that's the other part of this. What am I trying to find? Well, the problem says how many grams of our stomach acid will it neutralize? So I'm going to figure out how much HCl gets neutralized from this reaction. So you need to know a little bit about going from grams to moles, and the mole from that unit earlier on. But we're going to start with 24 grams of calcium carbonate. And we're going to make a T-chart. And you might remember that if I'm trying to change this from grams to moles, I got to have the same, whatever I have here, the unit has to go in the bottom kitty corner. So I'm going to change that to 1 mole of CaCO3. We'd look this up on the table. So like a calcium is 40, 1 carbon is 12, 3 oxygens is 48. So I'll just do some quick math for you. We add all those up and it comes out to be 100 grams on the bottom. That's off the periodic table. Now the middle part is the only part that's new. So the middle part, actually, when we want to change it now from one thing to the next, this is the only thing that you maybe haven't seen before. We've got to keep, again, kitty corner. Whatever's here has to go here. So I'm going to have moles of CaCO3 on the bottom there. And on top is what I want to change it to. So I'm going to change it to moles of HCl. Now the numbers that go with that, you notice I switched the color to green for a reason, are coming from the balanced equation. So the whole reason we had to predict this, the whole reason we had to balance, is because the numbers we're going to use in this middle part to change it from one thing to the next. So now, instead of looking at CaCO3, I'm looking at HCl. And the final step here, so it's a 3-part kind of conversion, is now I'm going to go right back from moles of HCl to grams of HCl. And 1 chlorine's 35, a hydrogen's 1, so I'll call it 30. I think it's 36.5 grams for the HCl. So you notice that these 2 outside things, they're exactly the same. They're like the exact same step, just kind of backwards. The only thing that's new would be this middle part where we've got to use the numbers from the balanced equation to change it from one thing to the next. So when we run this calculation, and our answer is 17.5 grams of HCl. And you'll notice that every question has the answers listed. So hopefully that is helpful, and talk to your instructor if you need a little bit more help. Thanks.